Our star pendulum has a famous sibling, and it is time they met. Take the pendulum and hang a second one from its elbow. That is the entire change. One more rod, one more joint. The rules are the same kind we have used all series. A differential equation that says how the two angles change, given where everything is now. Our steppers handle it without complaint. But watch what the motion looks like. No rhythm settles in. The elbow snaps, the lower arm whips over the top, hesitates, reverses.
It looks less like a clock and more like a thing trying to escape.
And yet every twitch you see is pure, deterministic law, computed by the same honest stepper from last episode. Nothing is random here, remember that, it is about to matter. Now the experiment this episode exists for. 2 identical double pendulums, released from starts that differ by 1/1000th of a degree of arc. A hair, far less than any measurement could ever detect. Watch the paths their tips trace. At first, one curve. The twins agree so perfectly you cannot see two. Then a whisker of daylight. And then they have nothing to do with each other. 2 histories from one indistinguishable beginning.
Then make the hair finer, surely enough precision buys back the future.
Here is the same release with the gap 10 times smaller. Agreement lasts a little longer, and then the same explosion. That is the cruel arithmetic of chaos. The error does not grow steadily, it compounds, doubling on a fixed rhythm. 10 times the precision buys a fixed few seconds every time. To predict twice as far ahead, you do not need twice the precision. You need the square of it. A fair suspicion. Maybe our stepper is the problem, planting tiny errors that chaos then amplifies. So let us be paranoid. Rerun the twin experiment with steps 10 times smaller. For each step size, plot the separation within its own twin pair on a logarithmic scale. At first, you cannot see 2 curves. They lie exactly on top of each other to the width of the line. Quiet, quiet explosion. Same shape, same moment, whatever we pay for precision. Then keep watching. Far beyond that prediction horizon, the 2 curves peel apart. The late details disagree, but the moment prediction fails does not. More precision changes the unknowable future, not how long it stays knowable. Sharpen the tools all you like, the divergence stays. Sensitivity is not an error our method commits. It is a property the system owns. The double pendulum stretches nearby possibilities apart, everywhere, all the time, and no stepper can integrate its way around that, because the equation itself is doing the stretching.
So a single trajectory past the horizon is not science, it is a coin flip.
Which tells us to stop asking for one trajectory. Before the honest move, one more witness, with higher stakes than any pendulum. 2 bodies under gravity, a star and a planet, are a solved problem. The orbit is a perfect ellipse. We have had the exact formula for 4 centuries, and eclipses are predicted to the second. Now add one more star. 3 suns pulling on one another and nothing else changed. Watch what gravity does with that. No ellipse, no rhythm. A braid that never repeats, drawn by the same honest stepper. This is the 3-body problem, the one the famous novels and the show are named after. And it fails the twin test just like the pendulum did. Here are 2 copies of this sky, one sun nudged by 1/1000th, and we follow that sun's path in each copy. They agree and agree. And then they are 2 different futures. In the story, a civilization lives beneath suns like these and can never know whether tomorrow brings a gentle era or fire. Their tragedy is exactly this picture. Poincaré proved, more than a century ago, that no formula is waiting to save them, and sensitivity does the rest.
So even the sky refuses long prediction. What is left?
The honest move. Here is the honest move. Instead of one starting point, take hundreds, all crowded inside the smudge of our measurement uncertainty, and integrate every one of them. Early on the cloud travels as a tight little flock. Any member is a fine forecast. Then it stretches into a filament, folds over itself, and smears across everything the system can reach. No single dot is trustworthy anymore, but the cloud itself can be. Its dense regions, its empty regions, and its overall spread can return from ensemble to ensemble.
If two experiments begin identically as far as we can measure but end differently, what is science supposed to reproduce?
Not a single path beyond its prediction horizon. Reproduce the distribution, across many trials, where outcomes cluster, how far they spread, and how often each event occurs. And more samples are not enough if they all repeat one guest start. The ensemble must fill the uncertainty our measurements and our model leave unresolved. So the answer changes kind. Where prediction ends, the trajectory dies, and a distribution is born. Not where will it be, but how likely is it to be here? This is not a consolation prize. It is how weather is actually forecast. Dozens of simulations from nudge starts turned into probabilities and checked against repeated forecasts. One thread remains for this series. Every system so far was a handful of numbers. Next time, the finale. We hand our toolkit a whole field,